Along India's vast coastlines lies a world of immense opportunities. But its secrets are locked away in a sea of data, siloed, complex, and fragmented. A challenge that has prevented us from seeing the bigger picture. Until now, introducing OceanSight, a unified marine data ecosystem. Here we use artificial intelligence to forge a national data backbone. Let's start with logging using test credentials. Logging in, we can see that there are 4 major modules: data exploration, otolith, eDNA, and fish taxonomy. We will begin with the data exploration module first. This module has 2 sub-modules, Chat with AI and data visualization. Let's go with Chat with AI first. Here, the user can choose from 3 modes depending on their needs. First, we will select Simple Q&A. This mode uses a vector DB and RAG system to provide contextual and summarized answers. For example, here we will type, "Our query is being processed." So this displays the summarized result about Atlantic herring. Next, we will select Get Data mode. In this mode, researchers can generate a custom dataset from our database. Internally, it uses an agentic workflow to fetch data from Postgres. For example, here we will type, so here we receive the data file about fishes data near Mumbai. So first we will download it. And now here we can see the detailed results. Now next we will select eDNA queries. Since the eDNA dataset is very large, we have kept it as a separate option. This mode combines our Postgres database with the BLAST API to provide more reliable results and avoid false eDNA positives. For example, so this displays sample details and species hits. The results show sample details along with 14 species hits. The top species is a fish with 12 hits and a score of 1316. Now let's move on to the next submodule, that is visualization. First we will upload a CSV file. So in this case, we will upload oceandata.csv file. Then we have 2 modes, manual mode and AI mode. Let's go with manual mode first. Here we can see the parameters that are present in the uploaded dataset. So from here, we can select the desired parameters between which we want to visualize the relationship. So in this case, we will select date and temperature. Now, our system very smartly analyzes these parameters and displays different graph types as options which are possible to be plotted by those parameters. Now, as we can see, the bar chart showcasing the relationship between date and temperature has been successfully plotted. Now moving to the AI mode. Here, the user can simply give a query. Let's say, now here, as we can see, the graph has been plotted automatically. Now let's move towards the otolith morphometric analysis. OceanSight has a specialized module for converting research images of otoliths into valuable insights through a CV pipeline. So first, here the researcher simply needs to upload an image of the otolith. And now here our image is being processed. So as shown here, the system outputs a processed image with boundary and estimated rings clearly marked. So we can see the estimated age of the fish along with morphometrics measures. And also, we can see the graphical representation of the otolith growth patterns. And moreover, the researcher is also able to export the analysis into a report. So as shown, we can receive the PDF formatted analysis report. Now let's move towards the taxonomy module. OceanSight features an intelligent system for species identification and classification powered by AI. Here, a researcher only needs to upload an image of a fish. Then the system automatically analyzes key morphological traits to suggest the most likely species along with a confidence score. The classification process is also backed by our own curated database. Now let's move on to the eDNA module. The eDNA module enables researchers to identify species based on DNA input. A DNA sequence can be provided either directly as a string or through a QR code that encodes the sequence. For demonstration purposes, we have included sample QR codes that can be scanned to quickly test the feature. The system analyzes the input and displays ranked data of fish species. And here we can see the details about species identification along with the confidence score. And here are the details about the top 5 most closely related species. Now we will see the map feature that we have implemented based on biodiversity records from Indian Ocean Biodiversity Information System. This feature allows researchers to interact with the map and explore species data directly through the filters given in the sidebar. The map highlights all the regions where biodiversity data is available, giving researchers an overview of species distribution across the country. Now, next I will apply another filter for genus Labio. The map updates to show only the regions where this species has been recorded. When I click on a region, detailed information is displayed. This makes it very useful for researchers as they can easily visualize species distribution and connect it with the underlying datasets for deeper analysis. Let's move on to the dataset upload section. Our automated AI ingestion pipeline integrates diverse, siloed datasets into a single ecosystem, processing them asynchronously based on system load. In this section, you can upload files in different formats, such as CSV, Excel, JSON, and more. For example, let's upload the file named oceandata.csv. While it is being uploaded, you can close the window and continue with other tasks as this action does not block user interactions. We have also documented our API to ensure that the data and features we provide are not limited to our platform alone, but can be seamlessly integrated into other applications, research tools, and systems. And with that, we come to the end. That was OceanSight. Thank you for watching our prototype in action.